What is on you? Take a look at this. Well, something to show you. We're going to talk a little bit about visualization. I thought, what a better way to kick it off than a little hand-drawn illustration action with some aha. Take on me in the background. Yeah? Dun, 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 dun. Come on. You guys are singing it with me. That's not really why we're here. Really why we're here is we're going to talk about visual data management. Now, what's the difference between visual data management and data management? Well, this is what you would typically see in a data management demo, right? God, that's a good tune. No, you don't like it? All right, we'll come up with something different. But anyway, take a look at this. What would you do with this? You'd print it out. You'd tape it to the side of your... Here we go. This is a much better tune. There it is. You'd tape it to the side of your monitor. You grab some highlighters, and you start checking off your work, right? Well, with Vault 2011 and Autodesk Inventor 2011, we're going to dramatically change the way that you interact with data. Now, I know that sounds crazy, out-of-the-world exciting, but really you're going to be surprised about this. Check this out. I'm running a report directly from Vault, right? Now, this report is going to tell me a couple things. Now, right now, it's telling me what's released and what's still work in process, right? So, that's great. It's fine and dandy. Maybe you want to customize it. Maybe you're feeling like a Miami Dolphin today. Who doesn't like the Dolphins, right? Let's go ahead and map that directly onto the CAD model. This is visual data management, ladies and gentlemen. So the ability to really go through and dissect the life cycle state. Maybe you want to go through and run another report. But then there's reports. You can set these up to display multiple pieces of information. These are completely configurable, right? So here I've got one, what's been assigned to an item and what hasn't been yet inside my data management system. Let's go ahead and keep cycling through these. Now, this used to be something I would search for all the time. What files do I have checked out? This is very relevant information, right? And then another one, maybe I want to determine quickly and easily, hey, which one of these are standard purchase components or off-the-shelf, standard length of beams and such, really something that's not engineered, right? So I'm able to even isolate. And notice by isolating the components, everything else kind of grays out. Really giving me a highly interactive, very intuitive heads-up display for doing simple tasks that you would normally do, right? So here I want to go ahead. These things are checked out to me. I want to check them back in. This is going to absolutely change the way that you look at data management. As a designer, as an engineer, man, I'll be the first to admit, I always thought that data management applications, they kind of impeded my progress. Well, here, this is a usable tool. Data management is no longer something just for management, right? It's something that you can use every single day and literally interact with your work. That, ladies and gentlemen, is visual data management, and I think it's going to dramatically change the way you look at data management. Just in case you didn't have the song in your head yet. That's a quality tune. Anyway, don't forget to follow me on Twitter and check us out, the manufacturing community, manufacturingcommunity.autodesk.com. Hit the note. There it is. I'm out.
Many designs require the creation of subassemblies which contain similar geometry, where only the size or position in the main assembly is slightly different. Instead of painstakingly adjusting the size of each copied element manually, use the new iCopy feature of Inventor to copy and resize your subassemblies automatically. iCopy enables you to easily customize commonly used assemblies by automating the process of copying and positioning similar components. iCopy automatically resizes multiple copies of standard elements to fit within a design by referencing a few key constraints such as connection points and paths. iCopy combines skeletal modeling and adaptability, allowing the subassembly to change in order to fit its position in the model. And because your 2D drawings in Inventor are associative with the 3D model, the drawings of each copied subassembly get updated automatically. iCopy can save valuable time for engineers who need to explore multiple design iterations of structural elements quickly.
Hey everybody, Rob Coe here, talking a little bit about what's new with Inventor 2011. And in this section, we're going to talk about tooling and mold, and the mold flow technology that we've built into Inventor Professional 2011. Now, let's take a look at the material library here. What a tremendously detailed material library that we have. Let's take a look at the thermoplastics of the material. We've got shrinkage property, filler property, recommended settings, so on and so forth, and even environmental impact of the material that we're selecting. So let's go ahead and take a look at some of the results of our initial analysis. And as you can see, the quality prediction tool allows me to determine areas that are sketchy, if you will, as it comes to my as it pertains to my design. So what problems can occur with a high stress? Well, it can cause some cracks in the plastic, and we certainly don't want that. And gives you some ideas as to how we can go about changing the design of this part to reduce the opportunity for error here. Now let's take a look at and see what the weld lines look like. Now, as this part is being filled, as the plastic comes together here, as you can see, there's it's trapping some air there and possibly giving me a weld line problem here. So I need to determine as a designer as to whether or not, what's the risk factor there, and determine if I need to change the design of this. Now let's go ahead and go through the process of creating the core and cavity. First thing I need to do is define the workpiece setting here. And really easy to use, easy to understand dialog box. And then I'll go on to creating the patching surface. Now, those of you who have done this manually in the past, or are currently doing this manually, you're going to see some of the things that you're going through and projecting edges and using a lot of project geometry and creating new surfaces and doing a lot of part splitting here, usually. But the tools that we have here are automating that process for the specific purpose of creating a core and cavity. So I've gone through, I've created a patching surface. Now I'm creating a runoff surface. And again, it's just analyzing the part. Now I'm ready to go ahead and create the core and cavity. As I preview it, it says, well, hold on, wait a minute. We've got an edge set here that hasn't been defined, and you need to create the patching surface for that hole. Well, let's go ahead and do that. Find that hole. Now that hole is a small hole and really easy to overlook during the process of creating core and cavity. And had we forgotten that, that's a costly error. So let's go ahead and preview what this is going to look like, and there we go. So let's go ahead and pull this out, clear body separation, and those of you that have been doing this manually may now pick your jaws up off the floor, because yes, it was indeed that easy. Alright. So we've got our core and cavity created. Let's go ahead now and take advantage of some new functionality here. And that's the patterning of these. Now, with 2011, I now have the ability to do a unique instance of this. So if we wanted to flip these around, I now have the base cover mold base 1 and cover mold base 2, and it's creating a unique instance of those during the pattern. Now let's go back into the mold design here. And let's determine the mold base that we're going to use. Are we going to use Futaba? Do we want to use a DME? Maybe we're going to grab a Hasco here. And which Hasco are we going to grab? Let's grab a Hasco number 1. Determine the size. And basically just select a reference point. And once I place that reference point and hit OK here, it's going to bring in a number of components for the mold base. Look at that. I didn't have to create them, I pulled them from a library, and it automatically positioned them relative to my core and cavity so that it's fully assembled. I didn't have to place a bunch of constraints. I didn't have to create the positional representations. They were created for me. I've got a master level representation. I've got a product open, ejection, close. Now, with this, we're going to be able to dynamically simulate the motion of the mold base assembly to easily examine the mold base components for clearance and interference. That's significant advantage versus doing this manually. So let's go ahead and go to the free drag mode, and as you can see, I want to make sure that these things are going to operate correctly, and when we go to eject the part, it's actually pushing the part out of the assembly here. All right, let's go back to master it. And there we go. Now, as you can see, the powerful simulation tools inside of an Autodesk Inventor 2011 merged with the MoldFlow product have been enhanced to make your life easier for you to create and validate multiple design iterations.
Visual appearance and fidelity of models within Inventor 2011 has been drastically improved. We now have realistic rendering that we can use directly within the modelling environment. This incorporates a consolidated high-quality visual materials library that is shared across other Autodesk applications, such as Revit Platform, Autodesk Showcase and Autodesk 3D Studio Max. Some of the other improvements are in advanced image-based lighting, and also a huge expanded materials library that we can make use of. First thing we'll look at is some visual styles. So we'll start by actually putting in model into perspective mode, like so. And you can see here now we have a number of visual styles that we can make use of within Inventor. So currently I'm just in a standard shaded view at the moment. But for example, I might want to have a look at some wireframe modelling with some hidden edges available. Other styles, maybe monochrome, or maybe for technical illustration purposes we could put it into just a line type drawing. So some great looking visual styles there. So to improve it even further, we can put on some real-time shadows. Now the shadows, we can actually just say, right, we'll only want ground plane shadows. And now if you have a look at the ground here, you can see we have some very nice soft looking shadows on the ground. Or we could now say, well actually I want object-based shadows as well. Or maybe even ambient shadows. Okay, so you can see that the visual fidelity of this is pretty high. Now, Inventor is now making use of DX10 and DX11 capable graphics cards. So you can imagine the performance has greatly improved, and also we're having much more compelling real-time graphics on the screen. But how could we improve this further? Well, let's now start to take a look at some reflections that we might want to use. Okay, so you can now see that the model is being reflected on the ground plane below. If indeed we wanted to show a basic ground plane, again we could make use of that and switch that on. So it's just a standard ground plane within Inventor. The lighting at the moment is just pure standard lighting, just driven by two lights that come with, as default within Inventor. One of the real nice features in 2011 is the ability to use image-based lighting and be able to have finite control over that. So, if we have a look at this, here are my lighting controls here. What we can actually do is we can actually switch it into image-based lighting. So as an example here, I'm going to put it into a warehouse environment. Now, what's happening at the moment is Inventor is actually using the lighting from an image that we currently can't see. But already you can see that there's a drastic improvement now to the actual lighting environment. If we want to, we can actually start to configure the lighting. So for example, I could go into settings here. What I might want to do within the settings dialog box is actually ask Inventor to show me the image. So there's the image that it's using at the moment. And now you can see the model is framed within this nice 3D image. Now, the actual size and feed of the image can be changed. So if we go back to the settings here, for example, I may wish to scale the model compared to the image, like so. Or I might want to actually change the orientation of the image as well, as you can see here. And again, you'll see that the lighting is actually responding in real time to these changes that I make. So the other thing that's quite nice is if you have a look at the shadows on the floor at the moment, they are quite hard in appearance. So what we're able to do is actually start to change the shadow appearance in real time. So first thing we might want to do is soften up those shadows. And you can see as I slide this bar, if you have a look underneath the accumulator on the ground plane there, you can actually see these shadows becoming smoother in real time as I drag this simple slider bar. And the same thing with the ambient shadows, we can make them darker or lighter. And again, it's just so easy to get this image looking just how we want it to look. Now, at the moment, we are still just using the Inventor shading environment. What we can do is make use of this expanded materials library. Now, as we've just said, Inventor now shares its high quality visual materials library with products such as Showcase and 3D Studio Max. So let's now switch on realistic mode. Okay, now you can see a big difference to the way these materials are appearing on the screen. Now if we start to zoom right away into the model, you can actually see the quality of these materials. Okay, so we've got this brushed stainless steel effect on the cylinders, galvanised effect on the main casing here. If we come around and have a look at the motor, you can see the bump map that's being used on this particular material. So how are these actual materials configured and set up? And again, as you'd expect with Inventor, it's very easy to do. You can just go into the settings area here. Go and have a look at our colour styles. And for each standard flat shaded material that we have within Inventor, we also have a high quality counterpart. And this will be shown in the realistic mode. So as an example here, you can see I've selected precast concrete. And in the basic material here, you can see we're showing concrete. We can set a texture up and maybe a bump map, or we can actually specify a realistic material. So if we go into the settings here and we now have a look at this advanced library, we can see that this greatly expands the possibilities of using realistic materials from within Inventor, especially when we want to relate Inventor with the construction environment, looking at things like concrete, brick, materials, glazing and so forth.
The purpose of this tip and trick is to really get everybody to understand and muse the fantastic features when it comes to selection and priority inside of Inventor. I often speak to so many people that always say they have difficulty with large assemblies, and this is just one small way in which that you can ensure that you're working and increasing your productivity. I have to say that when working with large assembly data sets such as the one I've got here, often selecting, turning things on and off and trying to handle visibility and that type of thing can really be a pain. And I actually in fact find that working with these selection priorities, which you can find up on your top of your screen here on your quick access toolbar, alternatively you can hold down shift, right click, and they're there as well. The default selection priority here is set to component. So you can notice that when you in actual fact are selecting components, individual components are obviously selected, but also note as well that with component priority we obviously will pick everything that's related to it, whether it be in a pattern or alternatively a whole sub-assembly. But what is actually quite good is the ability to even just use something as simple as part priority, because part priority gives you the ability to be able to maybe individually pick certain items, find where they are in the browser and that type of thing, because it's really difficult to try and hunt through as to where these sort of things can be often. And keep in mind, it's not just about a part priority by itself either, because if one had to in actual fact choose that you'd like part priority and had to select something, just keep in mind as well, you can probably group this command and you can say, well, find all the occurrences of that particular bolt. So you can see here that in actual fact selecting things, being able to turn them on and off, makes it a lot easier, much quicker, rather than for me to go and try and find them inside of the browser. One of the other things as well, which is very, very powerful within this, is the ability to also not only group something like part priority, but I could say, for example, pick that, but I could also do things like what's it constrained to, or even pick things that are relative to its size. And there are options to this as well. And then, of course, we've got things like a component offset and that type of thing. But if I had to say component size, you'll notice everything basically relating to that component size and less has in actual fact been selected. So you can see here within the dialog box we've got choices here as to whether you want at least or most. It specifies a size there, which you could maybe type in a slightly smaller or larger one if needed, and then of course move on from there. Keep in mind that there are quite a few of these to use. Again, part priority, you might want to go and pick, say, for example, this as well. And I might also want to come back over here and say that I'd like to do a sphere offset on this. So you can see that everything completely bounded inside of the sphere can be picked, all right, and can obviously really speed up things quite nicely. One of my favorite ones as well here is that, especially when you have a lot of things to be able to pick, is to pick by a selection of a plane. So I could say, for example, select that plane, and you can see everything within this side of the plane has in actual fact been selected. It's everything inside, but not